और अभी अब तो मेरे को अनम्यूट रहना ना, क्योंकि अब तो मेरे को रिकॉर्डिंग इससे होगा।
हाँ।
All right. So we'll start today's lecture by first quickly revising what we studied yesterday. We studied the basic paradigm of programming. We are doing three main things. One, take some input from the user. Second, do some useful processing. Third, give some output. We said that we can give the output using the print function. We saw that we can put comments using the hash or the pound symbol. We use variables to store something useful which we want to use further in our programs. So the term variable literally means that it's something which you can vary, you can change, right? So we say that x equal to 10 means that assign the value 10 in a memory location which we're going to refer as x. We saw the different data types you can use: integers, floats, strings. We saw that there are various things you do not want to be naming your variables as. Some Python keywords like false, none, true, etc. We also can't use variable names such as 1 or 1x, but x1, x_1, all of these are valid variable names. We discussed that the case is important. So, sorry, zoom in. So we said that capital X and small x mean different variables in Python. So it's a case sensitive language. We want to be using some good names for the variables. For example, here I'm using the first underscore number to denote the first number, second underscore number to denote the second number. We discussed about the different types: integers, booleans. We'll discuss a lot more about booleans today. Floats, strings. We saw a little bit about functions. So fx equal to sin x is one such function, where the name of the function is f, the input of the function is x, the output or the return from this function is the sinusoid of the value of sinusoid of the input x, right? So we saw that there are different kinds of functions. For example, type is a function. Name of the function is type. The argument is anything you want to put, any object that you want to put in that, and then you get the output as a type of that object. Print is a function also. So we saw that we can print type of 10. This will be first evaluating type of 10, and then it will do print of the type of 10. We saw type conversion. So we can convert this x equal to 100, which is a string, into an integer by using this int function, int function. We saw that if you type this int function on an input which is not an integer, you'll get an error. Invalid literal for int with base 10. So again, those of you who are curious, you should just read the statement: invalid literal for int with base 10. So since it mentions something like base 10, maybe it allows you to use some other base as well, right? This is just to whet your appetite, just to give you things to think about, to study in the documentation. I'm not going to tell you what is the base, what different bases are allowed, but this is something you should just study. We can find the number of digits in a number. We said that in a very easy way by converting that number from the integer value to the string value and just finding the length of the string. So length is again now a function which gives you the length of a sequence of characters or a length of a string. We discussed various mathematical operations. For example, x equal to 10, y equal to 5, we can do x minus y, x plus y, x into y, x raised to power y, x divided by y, x flow divided by y, x modulus y. Right? These were a few mathematical operations we saw. So some of you are asking that how do you figure out what to search for? So I go into my terminal. I type Python. I type help. It tells me various things I should be searching for: modules, keywords, symbols, topics. So maybe just search for topics. These are the set of topics which you can search. Now I notice here is that one of the topics is types, capital types. If I write about types, it tells me the type hierarchy. Right? This is how I discovered about types. So yesterday was the first time I actually looked into documentation to figure out more about types. But you can look at various other things also, like operators. That is also what we saw yesterday. These are the different operators. And we also get the operator precedence levels. Right? Everyone clear on how to search for something specific? But you'll have to spend a little bit more time. So maybe there are things you don't figure out on the first time. Just type for help. So I think perhaps some of you would have done this yesterday. Searched for types and you get something else. Right? I typed in capital types, I got something else. I typed in small types, I get something else. So these are the types. So it's a built-in object which tells you about the different types your Python objects can have. Right? Whereas in capital types, the documentation that we were getting was for the different data types. So it's a topic versus a class whose definition we are getting. Right? So in this case, the relevant documentation you want to search for is capital types. Right? You don't need to learn this. I'm just showing this for reference. Does this resolve the question for people who were asking how to search for a specific topic? Okay, any other question till now? So we looked at, sorry, what's the question? So we've also looked at flow division and modulus operators. So the modulus operator will remain a very important operator for us. We saw that we can use a modulus operator to figure out whether a number is even or odd. So we can basically write 1 is equal to 2 into 0 plus 1, which is the remainder. So if we do 1 modulus 2, we get the remainder 1. 2 modulus 2, we can write 2 equal to 2 into 1 plus 0. So if we do 2 flow division 2, the answer will be 1. 2 modulus 2, the answer will be 0. That's how the flow division and the remainder are connected. Whereas if we just wrote 1 divided by 2, the answer will be 0.5. Right? So 3 different important operations we can use, operators we can use. We saw the operator precedence. We saw that 1 plus 2 the relevant ordering. So we saw that in this case, the first in decreasing precedence will have raised to the power that will first get executed and then divided by, and so x, this will become 1 plus 2 raised to power 3 divided by 4 into 5. 2 raised to power 3 is 8. So 1 plus 8 divided by 4 into 5. Divide and multiply are at the same level. If you have two operators at the same level, you go from left to right. Therefore, you do 1 plus 8 divided by 4, which is 1 plus 2 into 5. And therefore, the answer is 11. Okay, we stopped at this point yesterday. Now let's continue our discussion on. So let's say if I wrote a program, something like x equal to 10, y equal to 20, z equal to x plus y, and x equal to z minus x, y equal to z minus y, print x, print y. What do you expect the answer, the output of this program to be? Right. So the important thing for such kinds of questions, and this may be a little slow for people who have already done programming, but we still need to do this exercise. So let me just show how to go about writing such programs line by line. So we have x equal to 10, y is equal to 20, z equal to x plus y, x equal to z minus x, y is equal to z minus y. Right. So maybe let's just use this pointer to show where we are in current execution, right? And let's just create a memory. Let me just also have print x, print y, and let me just divide this into, right, this is my program. This is my memory slash variables. And this is my output, what gets printed, right? So first, let's just go to line number 1. So let me just call this So first we execute line number 1. It assigns the value 10 to the variable whose name is x. So we create a variable x whose value is 10. Actually, let me do the other way around. So at this point of time, we have a single memory assigned, a variable assigned x, whose value is 10. Nothing gets printed. We execute the next line. Y is assigned the value 10. Is assigned the value 20. Line 3 executes. Z becomes x plus y. We get another variable, z, whose value is 30. Right? So again, z equal to x plus y means that calculate x plus y, assign the value to z. Line number 4, x equal to z minus x. Now, the value of, so this is important to note. So first, in such cases, we evaluate the right-hand side, right? So if you want to evaluate the right-hand side, what is the value of z currently in the table? 30. What is the value of x currently in the table? 10. So what we're saying is that at this point of time, this is equivalent to assign 30 minus 10 to x, right? X equal to z minus x. You first evaluate the expression on the right-hand side of the equality sign, which is z minus x. At this point of time, the value of z is 30. The value of x is 10. You evaluate the right-hand side, you get the value 30 minus 10. And then 30 minus 10 is assigned to x, right? Therefore, now the new value of x is 20. So then we'll just update this table. So this is how we update the table. The value of x at this point of time, the value of x is 20. The value of y is also 20. The value of z is 30. Right? We repeat the same procedure. Go to line number 5. Y is assigned the value z minus y. At this point of time, what is the value of z? 30. What is the value of y? 20. What is the value of z minus y? Assign 30 minus 20 to y, right? So therefore, the value of y now becomes 10. So we update the table. Again, we delete the value x, y, z. X is now 20, y is 10, z is 30. We go to the next line, line number 6. Print the value of x. So printing the value of x means taking this value kept in the variable x, printing it here. So therefore 20 will get printed. Next, execute line number 7, print the value of y. So the value 10 is printed. So initially we started with x equal to 10, and now x has become 20. And we started with y equal to 20, and y has become 10. Right? So what have we done to x and y? We have swapped these two variables. Swapped these two variables. Yes? Now, so you should expect such kinds of questions in your worksheets tomorrow to figure out that what is the output of some programs, of these programs. Right? So the important thing here is to go slow. If you've never done this before, go step by step. Line by line is what we went. Create these small tables, x, y, z. What is the value of each of the variable at different points of time? Cross the value when you update the variable. Importantly, you first start doing the calculations from the right-hand side of equality. Right? X equal to z minus x means evaluate, put the value of z, put the value of x, evaluate z minus x, assign this value to the variable x, which means that we are updating the value of x to the new value. So x already had some value. We are now updating the value. Yes. Any questions in this? Sorry. Both the variables. The question is in line 1 and line 4. The variables are so let's go back to the direction today. Variable is something, is a name given to something whose value can change. Initially, the value of x, the variable x, was 10, but at line 4, the value of that variable is changed. So we can change the value of a variable. That's what variables are for. You want to be changing the values of variables for your various problems that you solve. Yes, other questions? This seemingly simple program, if you figure out, if you master this, you will be doing fairly well in programming. Right? This technique, some people call it a dry run, and I just call it running your code on a piece of pen and paper. Right? So you don't need a computer to be able to practice such questions. And many of you are asking if you can get more questions. You can write such programs on your own and then run it on your computer to see whether you get the same output or not. Right? I could have put a print at different stages to show the progress of updation of these variables. Right? Any question in this? No? Okay, so I'm at this point of time, I'm using an additional variable in order to swap two variables. Yes. So this is also, by the way, question in the first lab. Let me just run this and show that this indeed works. X becomes 20, Y becomes 10, right? I could have swapped these values in another way. So some temporary variable I'm using, I assign that to X, X becomes Y, Y becomes temp. Right? So when we were discussing this in the lab, I was saying that, so we're using these three lines of code in order to swap X and Y, right? This may again seem a little foreign to you, a little new to you if you have never seen such things before, but you have been doing the same thing earlier also, many times earlier also. Just to give you an example, if we open a spreadsheet. So let's say this is row, this is name, row, name. Right, so I want to now swap these two rows. I want to be swapping row number 1 and 2 in this record. How do I do that? I will copy this row. I'll copy or move. So both of them are the same. So I'll copy this. I'll paste it to a new location, right? And I'll then move this, the second row to the first, and the temporary location, the temporary row which I created, back to the second row. And I can get rid of this row. Right? So this is exactly what we are doing in the Python program. We had X and Y. We assign the value of X to a temporary variable, assign the value of Y, current value of Y to X, assign the value of the temporary variable to Y, and that's how we have swapped these two variables. Yes? Any questions on this? Again, I would leave this as an exercise for you, homework exercise for you, not graded. But again, do a dry run or run this through pen and paper to confirm that this is indeed swapping out these two variables. Right? And then there is a more fun way to do this replacement. X equal to 10, Y equal to 20 without using any temporary variable. X equal to X plus Y. Y equal to X minus Y. X equal to X minus Y. So this seemingly confusing program also swaps out the two variables, right? So this would again be a very good exercise to work it out by hand. And let me just show that. I will actually just show the values as and when I write this. So X equal to 10. Let me just use this for my memory, variable X and Y. And so when I just execute this line X equal to 10, the value stored in X is 10. When I write Y equal to 20, the value stored in Y becomes 20. I write X equal to X plus Y. So what is the new value of X? So understand that many of you have already studied these concepts. I am not bothered I'm not worried if you're not understanding or hearing, but please don't talk. Yes, for those who already know these things, please don't talk and disturb the others. X equal to x plus y. The value of x now becomes 30. I do y equal to x minus y. What is the new value of y now? First, evaluate the expression on the right-hand side of equality. X minus y. So the value of x minus y at this stage is 30 minus 20, which is 10. So when this line executes, the value of y becomes 10. And now x equal to x minus y. So at this stage, x is 30, y is 10. So x minus y becomes 20. So this way, we've been able to swap the values of x and y without using any additional variables. Yes, it's a fancy little program. Any questions in this? Okay. So yesterday we discussed about the function int, or we wanted to change the type of a variable. So I want to show where this becomes useful. So whenever we take the input from the user, that I've been saying that comes as a string, right? So if I write some x equal to input and print type of x, right? So it's waiting for the input. I type 120, let's say. The type of x is still string. I typed in supposedly an integer value, but the input function always returns a string, right? Therefore, all of your lab questions which have been asking you to add two numbers, they require you to convert the inputs to integers and then do the additions. So if you wanted to write a program to add two numbers taken from user as input, you would perhaps write x equal to int input, y is equal to typecast the input and print x plus y. The first number is 10, the second number is 20, the output is 30, right? The inputs always give you a string. You'll have to appropriately convert into the type which you require in the program. Okay. So thus far, we've been looking at the case when we required two integers and we called input two times. Right? Sometimes, so in fact, has any of you heard of this phrase or this term called comma separated values? CSV, where are you heard of this term? So Excel or such utility, they want to store records. They want to be storing your rows as well as your columns, right? So one format in which you can store such data is comma separated values. So let's say if I wanted to store, I can have something stored as role, name, marks. And then let's say my role is 1, my name is alpha, my marks are 10, role is 2, and let's say marks is 20, right? So if you notice, I'm using comma to separate my values, comma separated value format, right? So this is a very commonly used format. You can in fact just copy paste such content, and hopefully this should work. And you see that it's automatically pasted in the right format in the spreadsheet software, right? So that's the utility of having something stored in comma separated values. And that's a very common way in which we can expect the input from the users, right? So thus far, we've been saying add two numbers from the users as inputs, where each number is requested via a separate call to the input. Right? But let's say if the user gives an input like this. This is my input. And the user gives numbers like 10, 20. And I want to add these two numbers. Right? So first, let's just take this input from the user. look at the type of my underscore input. What do you expect the type of my underscore input to be? String, because anything which comes from input, until and unless it's transformed via typecasting function, it will be string. Type of my input is string, right? But we importantly notice that the comma is used as a separator between the two different values. Right? You have two different values, 10 and y, and we're using the comma as a separator. So my input is a string. Strings, by the way, this is in Jupyter notebooks or in various nice shells. If you do a dot and you press a tab, you get all the methods which are available. So many of you sometimes ask, how do I figure out what are the methods which are available or the different functions you can call? So I can then do a tab complete on split, right? Let me just show what is the output of this. So it gives me, okay, actually, let me call it this way. Right. So does the output look correct? Does this output look something you would have expected? You are giving a string. You're saying that I want to split it on a comma. You get two numbers, not two numbers, you get two small strings. The first string is 10. The second string is 20, right? So now what you're getting is known as a list of strings in this case. Right? You're getting a list or multiple such strings. But for each of them, you would have to again convert them to integers in order to do the addition, right? So what I'll end up doing is, and this is a shorthand notation. This notation will become clear when we study lists. For now, just look at this line of code and just think this is the way things have to be done. So I'll use my input dot split. Right at this, sorry. So because I want to split on the comma. So at this point of time, my x is 10, but importantly, we need to also check the type of x. What is the type of x? What should be the type of x? String, because we split a string into something, it's a string. Similarly, type of y is still a string, right? So if we do x plus y, we get the wrong answer. Right? Some of you have been doing this in the labs. We again need to convert x to an integer, y to an integer. So what we do is x equal to int of x, y equal to int of y, print x plus y. Now the sum should be 30 as expected, right? So we've now seen two different ways of getting the input from the user, right? So one input, for each number that we want from the input, we successively call the input function. We convert the input from string to an integer, and then we add these two variables, x and y. But then we said that the input can often come in types like this, right? 10, 20. So in such cases, we need to first split 10, 20 into 10 separately and 20 separately. So therefore, we use a split function and we give the comma as the splitter. So it's also known as the delimiter, which is helping us split the string into two substrings, 10 and 20. Then each of 10 and 20. Now, at this stage, once you've written x, y equal to my input dot split on comma, you're getting two values x and y. That's the same as if you didn't use the input function, right? Then the program is the same. So int of x, y equal to int of y. So at this stage, the program is the same. X equal to int of x, y equal to int of y. X equal to int of x, y equal to int of y, print x plus y. Right? The only difference was in the beginning. Previously, we had each input giving you each variable. This time you had a single line of code, single line of input, which was separated using a comma. And then you split it using the split method in this, which is a string method. Any question in this? Sorry. Input 11. Input 11. Okay. Yes. So you have, this will get assigned the value x. sorry, X, this value will be assigned to X and this value will be assigned to Y. Right? There are various other ways in which we could have used assign X and Y. So once we study this, that will become more clear, more apparent. But this is one simple way in which you can still use. And get started with your programs at least so that you can submit your assignments and your quizzes and other. Yes, any questions? Yes, there is a question. Yes. Yes. So this comma is known as the delimiter. Delimiter or the string around which we will be splitting our input string, right? So just to work out more on that. So let's say first string was S equal to hello world, right? If we were to split this string on a comma, what do you expect to get? So there is no comma. So everything before a comma is assigned to the first variable in the output, right? So, but if we split this string on a space, how many entities do you expect to get out of the output? Two entities. One is hello, second is world. So if I do that split on space, right? Hello, world. We have two entities separated on the space, right? If we instead add hello world, India, what do you expect S to be? It will contain three strings. Hello, world, India. Yes. You'll have to be a little louder. Why are not using comma? Because we are not trying to split by a comma. We have to do an experiment. Hello, world, India. The problem is to solve it. Today, this hello world, India. By looking at space. So we do have spaces in this. So I have a space here. If you can look at my cursor, I have a space here, right? Everything before the space comes here. Everything between the first and the second space comes here. Everything after the second space, in this particular case, comes here, right? Instead, if we were having a string like this, then we want to split it via the comma. We still get the same out, right? Look at the first instance of a comma. Everything before the comma comes here. Everything between the first and the second comma will be this entry, and everything after the second comma, in this case, will be this entry. Is it clear? So there are other various combinations of this you can try, and you'll see that you'll hit some corner cases. But let's not discuss that. For today's lecture, I just wanted to, in this particular case, I just wanted to discuss this simple thing, right? And while we are at the topic of strings, we can, while we're not doing a full-fledged dive into strings, we can do some very small things with strings. So let's say if I had S1 equal to hello, S2 equal to world. If I do S3 equal to S1 plus S2, what do you expect S3 to be? It should be an error, right? How are you trying to add to non-number types? So we have studied maths. We cannot add hello to world. It doesn't make sense, right? But let's just run this program. We get hello world. So in Python, the operator plus will behave differently if you're surrounding it with strings compared to if you're surrounding it with numeric data types, right? So 1 plus 2 would mean different in comparison to the string 1 plus string 2. Here plus means something which is commonly known in the programming language as concatenation. You have the first string, you have the second string, you're putting both of them together and you're creating a new string. Right? Everyone clear on this? So let's say I wanted to use S1, S2, and I wanted to write hello space world. How can I do that? So, one at a time, yes. Okay, that's one. Yes. Someone was saying print. Okay, so there are multiple ways in which you could have done. So I'm saying that I could have done S3 equal to S1 plus a space. Right? The space is also a string. Like if you want to be very explicit, space is a string which is an empty. So there's just one space that I've pressed. And I could have done S3 equal to S1 plus space plus S2 print S3. Now get the space in between. Right? You are now adding or concatenating three different strings. You could have done this on arbitrarily long strings also. Right? So this also helps you solve one of your lab questions. But there's another interesting thing about the print function. So if we just go to the help, if we just look at the documentation for print, it says that it prints values to a stream. You can give a separator, which is a string inserted between values. Default is a space and end equal to new line, right? So we can very quickly just look into what are the various things we can do. So one interesting thing which you might not have seen, we can print multiple such things inside a single print. So previously we've been just using print S1. It prints hello. And then print S2, prints world, right? But if we could print S1, comma S2, right? You could have given arbitrary other things also. It prints hello world. It does seem a little disappointing that there's suddenly a space coming in between, right? S1 does not contain a space. S2 does not contain a space. Where is that additional space now coming in from? So the comma does not introduce a space. It's just that the way Python print works, we saw the documentation. So separator equal to space. So whenever you have more than one entry, you're trying one variable or one entry you're trying to print using the print function. Those will a separator, which by default is a space, right? Familiar hello world. S1 is print without the space. Print S1, print S2. But between S1 and S2, the separator is nothing, right? There is no space in between. I could have also done something fancier. I could have had this as a separator, let's say. And now I see hello, this symbol, then world, right? I could have chosen any fancy looking separator. Yes. If you want even fancier, I could have done something like this. Yes. If you wanted to get something even fancier, I could have also maybe written space here, right? Space was a variable, which was just an empty, just this one space. And now also we see something. You see, we have shifted a little bit to the right. Between space and S1, we have put in the separator. Between S1 and S2, we are again putting in the separator. Yes? Sorry, is a question? So, 29. So actually space is a little confusing. Let me write something else. Now, does it make sense? We are printing more than one value. We're printing three variables, Sn, S1, and S2. We're using the separator as that weird looking print. So between Sn and S1, we'll put this separator. We'll first print Sn. Between Sn and S1, put the separator. Print S1 between, so print Sn, which prints alpha. Put in the separator between whenever you see a comma, right? So this separator is put. Whenever you see, now you see S1, print the value of S1. You see another comma, you put this, and then you print S2, which is the last variable that you're trying to print. Right? This is a specific way in which we can call this function. Yes? Any question on this? How search all the operations? What kind of operations? So if you want to search the list of operations, I would. So you start with help, right? Then you go to topics, and here you have operators. These are the mathematical operators. Yes, other questions? Yes. Indentation error. Okay, so indentation errors, thus far you have not done anything which should require you to do indentation. Once you look into control flows, you should be looking at indentation. So we'll discuss that in just a couple of minutes. We'll start with that. Before that, any questions on anything we discussed today? How to print, how does the print work, how does input work, how do you split? Any questions? Okay. So which brings us to the next topic, which is Booleans. Right. So we've looked at the Boolean data type yesterday, right? If you remember. So we looked at, right? So we had integers, floats, strings, but we also had Booleans. So Boolean means that these can take only two values, true and false. Can anyone remind us where does the word Boolean come from? Why is it called Boolean and not some other arbitrary name? So it comes after the founder of Boolean, George Boole. Right. So Booleans will take only two values. In Python, we use TRUE to denote one or true or high voltage. So importantly, this is capital TRUE and not small t, or in other languages, you may have other expressions of the ways to write Booleans, and B is equal to false, right? So an important way, an important reason why we study Booleans is because we want to be checking for certain conditions. So how do you decide that should you be wearing a jacket or not? In the winter, how do you decide whether you should be wearing a jacket or not? If the weather is cold, then wear a jacket. Or if the weather is, so do you wear a jacket if the weather is not cold? Is there any circumstance you can wear a jacket if the weather is not cold? When you have fever. If I have fever, wear a jacket. If the weather is very cold, wear a jacket. So there are various conditions you have to check. Similarly, in Python, we can check on certain conditions in order to be able to do useful work. And those conditions are through the Booleans, right? So you want to check, is it raining? So the answer would be yes or no, or true or false. That's where we use the concepts of Booleans and program. So for example, if we come to a question. So the question is, let's take an input from the user and print whether the number is greater than 10 or less than 10. Right? Not a very difficult program, fairly simple program. So you said that to take the input from the user. So this is the first thing you'll notice that I always do. While I say that take the input from the user, but for the first run, I never take the input from the user. I hard code the value of the variable to do some checks. After that, when I'm confident that I'm doing something correctly, I move on to the next stage, which is taking the input from the user. Right. So this is just breaking down the problem into simpler problems. I take the value of x equal to 12. I check whether x is greater than 10 or not. Right. So this line of code, it is written as z equal to x greater than 10. It means assign the value x greater than 10 to the variable z. Right. Now, there are various such kinds of Boolean operations or comparisons which will lead us to either a true or a false. Right? So if x is greater than 10, will it be, so not in this case, can you get any answer except for true or false? The answer would be either true or will be false. Forgetting about the corner conditions. What about x less than 10? Again, the answer could be either true or false. Of course, they can be equal to x can be equal to 10 also. But for now, let's just consider the case x is not equal to 10. So x greater than 10 will be either true or false. X less than 10 will also be either true or false. So let me actually write these so that this becomes easier. This prints true if x greater than 10. Similarly, x less than 10, and otherwise it's a false. False if x less than 10, otherwise it's true. What if x is equal to 10? True if x is 10, otherwise false. So we have introduced a new looking term, equal to, right? So equal to checks for equality. Single equal to means assignment. Double equal to checks for equality. It checks whether x is the same value, x is storing the same value as 10. Right? So we've looked at two different kinds of operations. Print x not equal to 10. This will be true if x is not 10, otherwise false. Print x greater than equal to 10. This returns a true if x is greater than equal to 10, otherwise false. Similarly, you can have x less than equal to 10. Right? So we've looked at the different operations that you could have used for doing comparisons. Right? So let's just run this program now. Before running, what do you expect the answer to be? So you have five prints. Can someone tell me what do you expect the output of this small program to be? The first line, x equal to 12. Print x greater than 10. Is x greater than 10? The first line should be true. Second line, x less than 10. If the first one is true, the second has to be false. Third one, x equal to 10. False, x not equal to 10. True, x greater than equal to 10. True, because 12 is greater than or equal to. It's greater than or equal to, not greater than equal to. Greater than or equal to 10. If we run this, true, x greater than is true, x less than 10 is false, x equal to 10, which means that if the value of x 10, that's false. X not equal to 10 is true because x is not equal to 10. X greater than equal to 10 is true. Right. Now, I'd maybe perhaps just change this to 9. What should the output now be if I change x to 9? The first two will have to be swapped, right? So the first one is true, the second one has to be false, and vice versa. Okay, x equal to 9. Is 9 greater than 10? So the first one would be false. Is 9 less than 10? True. Is 9 equal to 10? False. Is 9 not equal to 10? Yes, 9 is not equal to 10. Is 9 greater than equal to 10? No. So that will be a false. So false, x greater than 10 is false, x less than 10 is true, x equal to 10 is false, x not equal to 10 is true, x greater than equal to 10 is false. And if I get if x equal to 10, if x equal to 10, x greater than 10 is false. So this was one mistake which some of you were making in yesterday's lab, when the question was to find the larger of two numbers. So you check, is the number 1 greater than number 2? Then you printed something, else you printed something, but you did not check for the condition when both the numbers are equal. So x greater than 10, false, x less than 10, false. So in such cases, you didn't end up printing any number. Is x equal to 10? Yes. X not equal to 10 is false. X greater than equal to 10 is also true because x is 10. Now you know. Now you know. Yes. So that is what I'm saying. So I was not expecting you to be finishing the lab lesson. I was expecting that you'll carry over it to the next lab. So that's so all of you will have to be a little patient. Don't hasten up. So any questions in these simple Boolean operations? These seemingly simple things will be a cause of a lot of bugs in your programs. Right. So therefore, again, I'm suggesting to break this down into simple steps. The question was to take the input from the user, but I have not taken the input from the user. I always want to test all of these conditions first. I often like to print the different conditions, verify, and then only go on to making the program more complex. And now if the question is to just take the input from the user, I take it as an input. I'll convert that input from a string to an integer. I'll check whether that number is greater than 10, less than 10. I'll do those checks. Yes. Yes, that's a good question. So the question is that, can you add more experiments? So how do you decide whether it's not something there, whether it's not for this clear comment class? How do you decide? Sorry. Hey, if health is good, then come. If health is not good, then but what if health is not good, but you have an expansion? We can't. If health is so irrespective of its health, if there is a quiz tomorrow, you will come. Until unless your health is, God forbid, it's not ready. It's very bad, right? So we can have multiple such conditions which we often want to check. Right? If condition 1 or condition 2, if condition 1 and condition 2, these are the various different kinds of operations you want to do. Right? So for example, I want to play tennis or not. How will I decide that? I will probably decide to play tennis if the weather is good. But if the weather is good, but my friends are not there, I will perhaps not go in. Right? So for me then, I play tennis when both the conditions hold true. 1, the weather is good. 2nd, my friends come out to play. But there could be another one of you who is very, let's say, social, very outgoing. They decide to play if the weather is good. They don't care about whether the friends are coming or not. They'll make you. Or they can also play if any of their friends are coming, even if the weather is bad. Right? So then you're combining these conditions in different ways. Someone like me wants all the conditions to be true. Someone like one of you could maybe be okay even if one of the conditions. So therefore, we can combine different expressions. So we can combine different expressions. Right, we can combine different expressions using three important symbols: and, or, not. So are these three numbers, these three operators sufficient for you to work in everything in Boolean algebra? Has anybody heard of what is the universal gate? Have you studied that? You studied that. What is the universal gate? NAND gate. How do you create that NAND gate? Not AND. So using that, you can create any other expression, right? But again, money, if you've not studied that, nothing to bother, nothing to worry. So what we're trying to say is that, so we can write something like, so has everyone seen the truth table for Boolean algebra? Anyone who's not seen that, who didn't study Boolean algebra in your school? I can show that. The first result is that of Byju's. Interesting. So here 0 means I just want to open up the image. So 0 means false, 1 means true, right? So what is 0 and 0, or what is false and false? Right. So again, you don't need to remember anything, just think of it in common sense. I wanted to check for some conditions. I will play if condition 1 is true and condition 2 is true. Like I will play when the weather is good and my friends are there. But if the weather is bad and my friends are not there, will I play? No. So false and false gives us false. False and true gives us false because I want both the conditions to be met. Then only I'll play. False, so true and false gives me false. True and true gives me true. And we can check this in true and true gives me true. True and false gives me what? True and false gives me what? So if you see that I've written this keyword and. Right. So this is the reserved word. False and false gives me false. And false and true also gives me false. Right? So in the truth table for and, we are able to get the output value of true only when both the conditions are true. Right? We can do the same thing, but instead of using and, we can use a or. So again, without remembering anything, or means that I will play if any of the conditions are true. In the playing example, I will play either if the weather is good or I'll play if my friends are there. But if both the conditions are true, I'll definitely. So true or true gives you true or false gives you true, false or true gives you true, and false or false gives you false. So if you contrast these two, I should actually write it this way so that it becomes easier. False or true, false or false, false or true, and true or false. So I've changed the order of printing. Any thoughts why I've done that? Why have I written the expression the previous way was also correct. There was no problem with that. Why have I written this expression in false and false first and then false and true? Not quite. You're on the right track, but not. So why have I written false and false first, then false and true, and then true and false, and then true? Yes. So 0, 0 in binary means what? 0, 0 means 0, 0, 1 means 1, 1, 0 means 2, and 1, 1 means 3. So we have 3. I don't know what happened, but let's continue. Any questions still now? So I can specific order. If you take all and you're looking at the when you're looking at the mark. So the first statement is the stations. The second is 0, 1 is 1. So you progressing from 0 to 1, then after the sequence or binary. Right, so that's the way we should count in decimal also. How do we do decimal counting? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you add 1 to the next digit, and then again 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 in the units. Okay. So now I'll write a simple program to check whether or to print whether a number is greater than 10 or not. We'll equivalently see the flow chart for it. And that will give us a very good handle on how to understand control flow structures in Python. Right. So we want to check if so print whether or not a number is greater than 10. So I'll for now, I'll again just put a single number instead of asking from the input. I'm using another keyword, F. If you notice, keyword again is fairly close to the way we use in English. If X greater than 10, colon, print greater, else print right. So this is a very small program, but I want all of you to pay a lot of attention. X equal to 12 is nothing new. Then I'm writing if X greater than 10. What does X greater than 10 evaluate to? X greater than 12 would be what type? Boolean. X greater than 10 would be either a true or a false, which is what we'd been discussing earlier. X greater than 10 would be either a true or a false, right? So basically what we're saying is if true or false, depending on the condition, if the condition is true, if this thing evaluates to true, then execute this statement. But if the above X greater than 10 evaluated to false, then go in this else block and execute everything below this. Right? So the indentation here is important. And I've also put, if you notice, I put a colon, right? So this is defining the scope of the block, right? X equal to 12, X greater than if X greater than 10. So basically, if condition is true, colon mark, then do something, else do something else. Yes? Yeah. Let me actually now draw a flow chart for this. So, okay. Okay, so our program was X equal to 12 if X greater than 10, print yes, else print no. Right? This is a program. Correspondingly, we can create a flow chart for this. So think of flowchart as an easier way to understand such control flows. So first our program starts. Then I define a variable X equal to 12. Then in the next line, I'm checking if X is greater than 10 or not. Right? So I check is X greater than 10. What are the two options I can have? Yes, no, or true, false. Right? So let me just write true. If X is greater than 10, then what do I do? If X is greater than 10, then what do I do in this program? Print yes. If X is less than 10, then what do I do? Right? So this is a simple flowchart. Actually, I should just end this. Right? So I've introduced different kinds of blocks also in this. right? So one, I have this. I have these two start and stop blocks. This is to show the start and the end of the program. I also have this squarish blocks, right? I have only a single squarish block here. So this denotes any kind of processing that you're doing, right? Let's say if you're adding numbers or deleting numbers, sorry, not adding, you're adding, dividing numbers, you're doing any kinds of operations on them, any kind of logic you're doing. Then I have certain condition checkings, right? Is X less than 10 or not? Right? Right. So this checks for the condition. And the specific path which is taken if it's true, it's this path. So it's these lines of code which will get executed. For the printing input output, I'm using this specific block again, which is slightly tilted rectangle, right? So for that, I'm using something like similarly print no. And if my branch is a false, I'll be executing this part, right? And X equal to 10 goes in green, right? So I've now color coded it all for you. Let's just walk over this program. You start the program. The first step is you assign the value of 10 to the variable X. X becomes 10. Anything that you put in the processing, any kind of variable assignment or processing that you do, goes in these rectangular blocks. Second, you're checking for conditions, X greater than 10. Can I have everyone to please, can you please keep quiet? I understand that you may know these concepts, but please can just hold on for a few. Right? If X greater than 10, then if the number is indeed greater than 10, then you go in this true branch, right? And you print yes. But if the number is less than 10, for example, if the number is 5, you go in this branch, you print no. Irrespective of whether you go in this branch or you go in this branch, the program will end. Right? Any questions in this? So importantly, we're using this colon to indicate the scope. So everything important if you notice. So everything which is happening when this condition is true, right, is coming in this branch, right? And everything which happens here is coming through this branch, right? So this is one simple thing that you could have done. But we can have a more complicated, slightly more complicated program also, which will, let's say, have multiple lines here or multiple lines here, right? So therefore, the scoping is important to understand. Any questions in the syntax? How many spaces do you think I'm using before print? One space? So I'm using 4 spaces. I was expecting you to ask this question. Right? So if you don't know, you should be asking such questions. I'm using 4 spaces, which is the de facto in Python. Sometimes you use the tab, but in many languages, in many editors, it's often the case that we set a tab to mean 4 spaces when you're dealing with programming. Right? So Python is in Python, indentation and spacing is important. So the program would mean very different if you didn't put this indentation. Right. So this indentation means that everything which is, can everyone please keep quiet? So this is one of the areas where a lot of you will make mistakes. That's why I want you to please pay attention. This is perhaps the last topic we'll study today. You can then go for lunch. So we can then write slightly more complicated programs. Right? So this program is only doing one thing, checking whether the number is greater than 10 then it prints yes, otherwise it prints a no. So can any of you suggest me some ways in which we can modify this program to make it slightly more useful? Anything you want to add or delete? So before that, actually, let me just show a different program, slightly different variant of this program. So first, let's run this program. What do you expect to get printed? Yes. If I change the input to 9, no is printed. But let me just add some more things. Print X. Now let me just make this is our number. Print. We are done with checking. Yes, we have made the program slightly bigger now. X equal to 9, print X is a number. What does print X comma is a number do? What is the type of X? Integer. Is the number is a string, but print will handle this. You can have multiple different types to print, it will still work out. Now, if you run this program, what do you expect the answer to be, output to be? So first, this line gets executed. 9 is a number. 9 is 9 greater than 10? No. So therefore, it does not go in this block. It instead goes in this block, prints a no. And then after finishing it prints, we are done with the checks. 9 is a number? No. We are done with checks. Right? Now, this is important to come back to the context of the flowchart that we had drawn. So we've modified the program ever so slightly. Now our program is something like X equal to 9. Print X is our number. If X greater than 10, print yes, else print no. And then irrespectively of which branch it took, you are printing, let's say, done. Right? So if we create the equivalent flowchart for this, you start the start state, put X equal to 9, print out something, check is X greater than 10. You have a yes branch, you have a no branch, you print something here, and now irrespective of what branch you took, you will print done. You'll be printing done, and then you'll have a stop. Right? So if you contrast this program with the previous program, there you were not printing anything before, and now you're printing before all these ifs and after all these ifs also. Right? But then you can have further fancier variants of this. So let's say if X is greater than 10, I want to print X plus 10 also. How do I modify this program then? Only when X is greater than 10, I want to be printing X plus 10. So I can then modify this program. If X greater than 10, print yes and print X plus 10. Of course, this will not give you any different output because X is not less than 10. But if X is 12, we now see something different, right? So this is important to now notice that the indentation does matter and the blocks can be of variable length, right? So the kinds of mistakes that some of you will end up doing is things like this, right? So now this print X plus 10 is at the wrong location because you have not finished the if else block. So you get else gives you a syntax error, right? So we've looked at if else. I think we'll just stop at this point. We'll meet again tomorrow. We'll look at different kinds of conditional blocks. If else is one, if simply using if is another way. We can also use if, else if, else if. So there are 3-4 different variants which we can use, and then we can solve fairly complicated problems. So again, repeating the instructions. We'll have a quiz tomorrow during the morning session. Quiz / worksheet during the morning session. It will be printed sheet given to you. Second, we'll not have lab sessions tomorrow and Thursday. Instead, we'll have them on Thursday and Friday. So section 1, 2, 3, 4 will have your lab sessions on Thursday. Section 5 will have your lab sessions on Friday, same time, same everything. Just opted by 1 day. We will have an extra session tomorrow 4 p.m. where we'll cover some more topics in the same location. Thank you.